Whether you eat fish or not, the problem of overfishing drastically affects your community and the ecosystems around you. Levels of overfishing are already 3 times of what they were in the 1970s, and nearly 40% of fish species are farmed at unsustainable levels.
Not only is this detrimental to communities that rely on fishing for a living, but also impacts nearby habitats where fish like the southern flounder, Pacific bluefish tuna, and weakfish play an integral role in maintaining the ecosystem. NC is facing a fish crisis, but we think we found the solution.
Our solution is a Smart Buoy, a high-tech, cloud-connected, floating sensor that tracks pH, dissolved oxygen, turbidity, fish populations, and sonar signatures to monitor ecosystem health and potential overharvesting in real time.
Smart Buoy directly supports SDG 14.4 by promoting sustainable yield, enabling science-based zoning, and protecting the livelihoods of small-scale fishers through early warning systems that can be used to enact better policies and allow fish populations to regrow in time to keep up with the fishing industry. Phase 1 starts at Jordan Lake here in North Carolina. By 2027, we aim to deploy this technology across more coastal zones in North Carolina, and then eventually, by 2030, U.S. coasts and marine protected areas globally, with policy feedback loops at every stage.
We'll begin with 2 to 5 demo buoys using recycled PVC and a LoRa mesh network. We'll validate fish movement mapping, gather data, and work with local environmental groups.
Each buoy costs around $460. That includes the sensors, solar setup, and electronic and network costs, such as a LoRa board and an Arduino Uno.
Possible funding sources include NOAA research funds, GIF grants, prizes from the UNDP Ocean Innovation Challenge, and financial support from the NSF. Our solution will be to save both marine life and enforcement costs.
Each of the buoys uses off-the-shelf tech, recycled materials, and modular systems for the pH, turbidity, oxygen, and more. We're also using a waterproof casing to prevent the pollution of our waters.
We'll need environmental science interns, student engineers, natural resource volunteers, and partnerships with similar organizations like the NOAA for testing and scaling.
Our build uses recycled PVC and anti-fouling coating to prevent algae buildup. AI filters through sonar data to minimize any confusion or disruption. Our priority is low-impact, long-life design.
We also plan on using rechargeable solar panels to save costs on replacing the battery. More importantly, this design method allows us to create low-cost models that can be employed in rural communities. And the power-saving technique this buoy uses allows it to shut down all non-essential functions when the power gets below 20%, but still allows it to monitor basic sensory properties.
By 2027, we predict 85% biomass estimation accuracy and predictive zoning tools that will help pass new harvest laws based on live data. This will help preserve fisheries without collapsing entire populations.
Challenges like sonar controversy or vandalism are real, but we're countering them with phased testing, low-frequency pulses, and a secure mesh design. Risks include sonar impact on species, disruption of habitats, and legal pushbacks in specific protected zones.
But rest assured, we have 2 strong ways to combat these risks. First, to prevent the sensors from disrupting aquatic habitats, we plan on employing passive sensor methods, including underwater cameras and collecting environmental DNA to monitor fish species, instead of using active sonar. And second, in order to ensure our device isn't interfering with fish breeding periods, we will carefully employ it only during non-breeding periods.
Here's a look at our working prototype. It has real data straight from the water, being sent to the cloud in intervals. This is compact, low cost, and very scalable.
The final goal is our informative dashboard that shows fish populations, threats, and reports of potential illegal activities for each location in real time. This makes aquatic zoning and policies more predictive and not just reactive.
So, how does this help fish and fishers?
The Smart Buoy supports sustainable harvest and protects small-scale fishers by providing visibility into fish movements and stock health.
This is more than just about just a fish. This is about equitable food access, environmental justice, and preserving aquatic biodiversity for future generations of fish and fishers.
And that's us, the Bluemetrics team. Join us in protecting life below water.